So, recapping what we did on last week, Thursday. So, rational functions take two different forms. They're either a reciprocal function or a standard polynomial at the top, polynomial at the bottom. So, the main things that we need to find are first zeros. So, to find a zero, you take the numerator, set it equal to 0, or take the equation, set it equal to 0, and cross multiply. Vertical asymptotes, take the denominator, set it equal to 0, and then solve it out. Horizontal asymptotes, if it's a standard reciprocal function, then it's whatever the k value is. If you have a polynomial at the top and bottom, then you look at the degrees and determine which one is bigger. If the top is bigger than the bottom, then there is no horizontal asymptote. If the top is less than the bottom, then the horizontal asymptote is 0. If the two degrees are equal, then you divide out the coefficients in front of them. So when they're polynomials, it's a little bit more work that you need to do. Lastly, a point of discontinuity. You simplify the fraction. Whatever cancels out, you set it equal to 0 to find the x value of the whole. And then you take that x value and you plug it in. So notice on Thursday, for one example, there was a hole in the graph. For one example, we didn't have a hole in the graph. So by all means, a hole is not required. It's not required to have a hole in the graph. So if you don't get a hole in the graph, it's not the end of the world. So that's a brief recap of what we did on last week, Thursday. Now we're going to put it all together into graph. So this is all the nuts and bolts stuff before we actually get into graphing. So again, some of this will be using the graphing calculator. So please make sure you have it out, available, etc. So when we are graphing a rational function, there are 5 things that we need to do. Well, 4 things before we can let the calculator do some work. So we have zeros, find the zeros, find the vertical asymptote, find the horizontal asymptote, find the holes in the graph, if any, and then we use the calculator. After we finish the graph, then we can do the domain and range. So everything that we did on Thursday, we now will use when we're doing the graph. So now let's put it all together. So let's start with the zeros. Zeros is when you take numerator, set it equal to 0. So that gives you 6 equals 0, which doesn't exist. That part doesn't exist. So that doesn't mean that no zeros exist. That just means that based off of the way the function is set up, we can't solve them ourselves. So they probably will show up, but based off of the function we have, we can't solve for them right now. So those are zeros. That's how we would solve for a 0. Vertical asymptote is next. Vertical asymptote. Take your denominator, set it equal to 0. Take your denominator, set it equal to 0. So you have x minus 2 equals 0. So x equals 2. So your vertical asymptote is x equals 2. So this is how we handle a vertical asymptote. So for vertical asymptote, we'll go to your graph. Go to the x-axis, go to 2, and draw a broken up line, a broken up vertical line, down x equals 2. Now, if you draw a solid line, I personally don't care, but you need to make sure that you have a line. So you need to make sure that you have that line. So that is your vertical asymptote. Again, I don't care if it's solid or if it's dotted, as long as the line is there. Any questions before we continue? You good? Yeah. All right. All right. Horizontal asymptote. So again, horizontal asymptote depends on what type of function you have. So this type of function is a reciprocal function. So if you're wondering, how do I tell the difference between a reciprocal and a standard rational function? A reciprocal function is going to have a number sitting on top of the denominator. So it's going to have a number only sitting at the top of the fraction. So since this is a reciprocal function, your horizontal asymptote is equal to the k value. The k value is the number next to the fraction. So your horizontal asymptote is y equals 3.
I wanted to do Rustin, so I want to talk to him when you're done with class today.
All right. So horizontal asymptote is y equals 3. So horizontal asymptote means horizontal line. Go back to your graph. Go to y equals 3. And you draw a horizontal line. So again, if it's solid, I don't care. If it's dotted, I don't care. Either way, I don't care. As long as you make sure you have the line. So when I check your graph, you should have a vertical asymptote. You should have a horizontal asymptote. Any questions before we go to the holes? All right, so we got vertical, we got horizontal. So, holes in the graph. So in order to do a hole in the graph, you have to simplify the function. So 6 over x minus 2, that's not going to be simplified. So since this is not going to be simplified, as far as holes go, there are none. As far as holes go, there are none. So reciprocal functions, you don't have to worry about finding holes. So now the only thing that's left is for us to use the calculator to fill in the rest. So now the calculator is going to basically take care of the rest of this problem. So let's go ahead and switch over to our graphing calculator. So, graphing calculator. Let's see. Do you have one? You want to use one? You have one? Yeah, you might want to go ahead and take that. So, go to y equals. So you have 6 divided by. Now, what I strongly suggest you do is put your denominator in parentheses. What I strongly suggest you do is you put your denominator in parentheses. So the denominator was x minus 2. So 6 parentheses x minus 2, close parentheses, and then put the plus 3 behind it. So 6 over x minus 2, close the parentheses, plus 3. So when we press graph, notice that it shows us roughly what the graph should look like. Shows us roughly what the graph should look like. So we should have our 2 branches. Now we use the table to get our points. Hit second, hit graph. Now we're going to let the table. Now we're going to pull numbers off the table. So, a couple things I want you to notice. Oops. I should have drew a line through that, but x equals, so notice that x equals 2, it says error. You're supposed to see that. Why? That was the vertical asymptote. This was your vertical asymptote. So it should say error right there. So with the vertical asymptote, pick 3 points to the left of it, pick 3 points to the right of it. Pick 3 points that are easy to graph. So don't make it harder on yourself. So -1, 1, 0, 0, 1, -3. I'm going to pick those points. 3, 9, 4, 6, 5, 5. I'm going to pick those points. Again, don't make that part harder than what it needs to be. I'm going to write it down for myself so that I don't have to keep bouncing around. 4, 6, 5. So now we plot the points on our graph. -1, 1, 0, 0, 1, 1, 2, 3. So there's one curve. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 9. There's the other curve. So all of your functions should have 2 parts, 2 branches. There should not be any straight lines other than the vertical asymptote and the horizontal asymptote. So those are the only 2 straight lines should be the vertical asymptote and the horizontal asymptote. So give you a moment just to get caught up here while we're taking that quick moment. Any questions before we move on to the next graph? Again, if you have questions, please make sure you ask. Number 1, closed mouths don't get fed. Number 2, so since I now have a student in the room, they're going to have much more access to asking me questions than anyone else. So when you are doing your graph, don't just draw two curves and expect me to just believe that that's what it was. I will go and check the curve. If you just go draw two squiggly lines, chances are I'm going to mark that wrong. So if you turn in crap, I'm going to give you a crap grade for it. So you do that at your own risk. Any questions before we move on to our second graph? That's how it's been looking all year long. Talk about how it looks on the screen. I've been seeing this all year from a teacher's point of view. I haven't seen it from a student's point of view. That's true. All right, 13. So 13 and 14 are your standard rational functions. We still follow the same rules, same things that we did up above. So we start with zeros. So we start with our zeros. Take the numerator, set it equal to 0. So 2x equals 0 means that x equals 0. So that means, since I now have a 0, that goes on the graph. Zeros are also known as x-intercepts. Go to the x-axis, put a point on 0. That's one thing that goes on the graph. Vertical asymptotes means take the denominator, set it equal to 0. So it's x squared, so you know what's coming after that. We need to factor this using MAF. So two numbers that multiply to -10 add to -3. X minus 5, x plus 2. So x equals 5, x equals -2. So yes, you have two vertical asymptotes. You have two vertical asymptotes. There's no rule that says you can't have more than one. There's no rule that says you cannot have more than one vertical asymptote. So that means you're going to have two vertical asymptotes on the graph. So you're going to have one at x equals -2. And one at x equals 5. So you have two vertical asymptotes. Any questions so far? So we've got vertical. Now let's go get horizontal. So horizontal asymptotes. So horizontal horizontal asymptotes. Now we look at the degrees. So you have 2x, so the degree at the top is equal to 1. The degree at the bottom is equal to 2, x squared. So your top is smaller than the bottom. Top is smaller than the bottom. Your horizontal asymptote is y equals 0. So you'll put a horizontal line through y equals 0. That means when we finally draw this curve, it's going to flirt with that line, but it's not going to touch that line. It's going to flirt with that line, but it's not going to touch that. It will flirt with the line, but it will not touch it. So, last thing before we use the calculator are finding holes, if there are any. So to find holes, we take our original function, we simplify it. That's 2x over x minus 5, x plus 2. Factoring the denominator shouldn't be that hard because you did it already when you found the vertical asymptotes. Notice we did it already. And nothing drops out. So since nothing drops out, there are no holes. There are no holes in the graph. In order for you to have a hole in the graph, you need something to drop out. You need something to cancel out in order to have a hole in the graph. So just remember that part, especially when we go to example 3, because I believe there's a hole there. So we found all the parts that we need to find. Let's go let the calculator do the work. So, any questions before we get to the calculator? You need a moment? All right, so let's let the calculator do its work. Go to y equals, clear out what we had. So you've got 2x. So your numerator is okay. You don't have to put the numerator in parentheses. If you choose to, that's fine. So 2x divided by the denominator, you need to put in parentheses. That's x squared minus 3x minus 10. Check just to make sure that that's what it was. So again, we can take a peek at the graph to see what it's going to look like. So notice that you have a few branches. Now you have 3 parts. Now you have 3 parts of the graph. So if you have 2 vertical asymptotes, you're going to have 3 parts of the graph. That means if you have 3 vertical asymptotes, you're going to have 4 parts of the graph. The more vertical asymptotes you have, the more parts of the graph you're going to get. More parts of the graph you're going to get. I'm not working. You forgot your divided by, separating 2x divided by. So, sorry. So, you have your three parts. This is what the graph should look like. Now, for those of you who don't have graphing calculators, again, I will send you a link so that you can use your Chromebook as a graphing calculator. If you want to use Desmos, that's fine. Do not just cut and paste a picture from the computer and then use that as your graph. I will give you a 0 for the whole assignment doing that. If you don't have a graphing calculator, okay, you don't have a graphing calculator. You do have two hands. Draw it out. So if you do that, just know you're signing up to get a 0. And if you do that on the test next week, you're signing up to get a 0 for the whole thing. Yes, you get it for one problem, and I'm going to give you a 0 for the whole thing. So please don't be that person that thinks that Mr. Lowe's not going to do it. You should know me better than that. So we know what the graph looks like. Pick second, pick graph. So now we're going to get our table. So unfortunately, in this case, there's a lot more decimals that we're working with. Unfortunately, that kind of is what it is. So think about what your vertical asymptotes were. So one of your vertical asymptotes was -2. So that means you're going to pick three points before -2. One of your vertical asymptotes was 5. You're going to pick 3 points after that. So what do we do in between? You pick 3 points in between. So you're going to end up with 9 points on this graph. You end up with 9 points on the graph. Which points you pick, that's purely up to you. Now, since a lot of these are decimals, you're going to be doing some estimating. That's okay. You're going to be doing some estimating because you have a lot of decimals. That's okay. So since -2 was a vertical asymptote, I'm going to use -3, -0.75, -4, -0.4, -5, -0.3. In the middle, -1, +0.3, 0, 0, 1, comma, -0.2. So, since 5 was the other vertical asymptote, so 6, comma, 1.5, 7, comma, 0.8, and 8, comma, 0.5. So, does it get a little bit harder when you have decimals? Yes. So, it's an estimate. These are estimates. So these are estimates. So it's time to graph all of our estimates. You okay over there, Noah? Don't worry, you'll have some people to talk to probably next period. Or at least wave at. Okay. So again, I'm writing down the points for myself so that I don't have to keep going bouncing back and forth. So now we go and put them on our graph. So when you put them on the graph, again, the main thing is for you to give a good estimate as to where they are. I'm not going to super penalize you with a decimal. If they were whole numbers, then yes. So -5, 1, 2, 3, 4, 5. So 0.3 would probably be somewhere right there. 1, 2, 3, 4. 0.4. And then -3.75. So again, notice that the points are real close to each other. But that's why I looked at the graph, so I know what it's supposed to look like. That's why you look at the graph first, so that you know what it's supposed to look like. Do the same thing for the middle. -1, 0.3, 0, 0, and 1, 0.2. Six, 1.5, 7, 0.8, 8, 0.5. I gotta check that one just to make sure that I'm not supposed to cross that. So there's your graph. So again, the main thing about your graph, if you have a graphing calculator, then you have an advantage. If you don't have a graphing calculator, you can go to Decimals. You can go to Google, type in decimals.com. You can type in the function, and it'll show you roughly what the graph's supposed to look like. They'll show you roughly what the graph's supposed to look like. No, it's rubber graph. You do this graph? Oh. Draw the other part of it. It's supposed to be 3 parts. Don't do here what you wouldn't do on a quiz or a test, because you know I'll mark it wrong if you don't have those spots. All right. We'll give you a few more moments to finish up example number 2 before we do our last example of graphs. Yes, it is a little bit more tedious and time consuming when you have decimals. Fortunately, there's no way around that. Okay, for those of you who are at home, if you have questions, please ask, because close not going to get fed. So let's do our last example. So, last example, same rules apply. Start with your zeros. Take the numerator, set it equal to 0. So again, as I mentioned the entire unit, factoring is major. You have to know how to factor. So this factors to x plus 2 and x minus 1. So x equals -2, x equals 1. So those are your zeros. So those are your zeros. Plot those on the graph first. And you're stuck somewhere, don't be afraid to stop me and ask. It definitely sucks if you have a question and you don't ask it, and then I can't help you. Vertical asymptote. Take your denominator, set it equal to 0. So that's another factoring problem. So you MAF it, that becomes x minus 7 and x plus 2. So x equals 7 and x equals negative 2. Those are your vertical asymptotes. So now we know where the vertical lines are going to go. So now we know where the vertical lines are going to go. One of them's going at negative 2. And one of them's going to go at 7. So I do want you to notice something. You have a 0 and you have a vertical asymptote in the same place. You have a 0 and a vertical asymptote in the same place. That means you know what one of your holes is going to be. You're going to have a hole at negative 2 comma 0. They both can't be there. You're going to have a hole there. So instead of a solid dot, put an open circle. So you have an open circle at negative 2 comma 0. So that's how you draw a hole. You just put an open circle on that point. Any questions before we continue? So again, notice each graph that we've done has gotten more and more complex. More stuff is coming to play. All right, horizontal asymptote. Horizontal asymptote, we look at the degrees. So that's the top and that's the bottom. So the degree at the top is equal to 2. The degree at the bottom was also equal to 2. They matched. They matched. So since they match, take x squared divided by x squared, which is 1. So your horizontal asymptote is y equals 1. You literally just divide out the top parts, the top and the bottom. Go to your graph. There's your horizontal asymptote. The vertical asymptotes and the horizontal asymptotes should be very, very precise. The only things that I'm not going to really trip about are those things that are decimals. If they're decimals, I won't really trip about those. But if they are whole numbers, if you don't graph those right, then yes, I'm going to mark those off. I'm coming for those. Holes in the graph. We already know that one of the holes is negative 2 comma 0. You straight over there, Noah? One of the holes is negative 2 comma 0. We need to see what else there is. So take your function. So we've already factored the top and the bottom because we solved them elsewhere in the problem. So we know it's going to drop out. X plus 2. We know those are dropping out. So when you find a hole in a graph, this was one of the extra credit questions from your quiz last weekend. You simplify it, whatever cancels out, set it equal to 0. So that's x equals negative 2. So now we take negative 2 and plug it back into whatever's left over. So your leftovers is x minus 1 and x minus 7. So negative 2 minus 1, negative 3. Negative 2 minus 7, negative 9. That's 1/3. So your other hole in the graph is negative 2 comma 1/3. So that's the other hole that would show up in the graph. So hopefully it won't be something that we have to plot, but if it does, it will plot. Any questions on finding the parts before we finish off the graph? Most of this is a calculator problem now. So in your case, when you put it in your calculator, I'll probably put both parts in one. Just don't forget the division side this time. So for a problem like this, I would suggest you put both parts in parentheses. Do this. So put both parts in parentheses. So x squared plus x minus 2 divided by x squared, make sure I do this correctly, minus 5x minus 14. So again, I'm going to take a sneak peek, see what the graph should look like. So there's my sneak peek of what the graph should look like. So now, go to my table and start filling stuff in. So notice that negative 2, there's an error next to it. That's where one of our holes were. So we would pick 3 points after it. The other was 7. So I've got 3 nice and neat points. And in the middle, there's a lot of middle too. There's a lot of numbers between negative 2 and 7. So you've got 3, 4, 5 possible points to pick. Just pick any 3 and draw a curve. And then those points I'll plot before we upload this to the class. So, any questions on the last graph before we get ready to close up shop? So, graphs aren't difficult, they are tedious and will take time. They are tedious and will take time. So, over there.